Okay, so my next definition that we're going to talk about is a probability model. And so a probability model is basically a list of the outcomes. So it's S, capital S, the sample space, but along with their probabilities. All right. Let's do a little bit more complicated model than we've looked at before. Let's say, for an example, we roll 2 dice. And we look at the sum of those dice. Just like we were playing a game, all right? So S, so the outcomes can be anything between what and what. So what's the smallest roll of the dice? So snake eyes, a 1 and a 1, so that's a 2. And then it can go all the way up to 12. So let's try to write this along there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so here's the probability of the outcome. So the only way to get snake eyes is for both dice to be a 1. So there's a 1 in 6 chance that the first dice is a 1 in 6 chance of the second, and we multiply that. We'll talk about that, the multiplication rule later, but that's 1 in 36. And similarly, for a 12, I got to get 2 6s. Okay, so already, just by me putting those two in, these outcomes are not all equally likely. So rolling a 6 is going to be more likely than rolling a 2. And so these are not the same, all right? Because, and the reason is because, like with a 3, if you divided the dice up into the first dice and the second dice, you can have a first one a 2, the second one a 1, or the first one a 1 and the second one a 2. So there's 2 ways to do this guy. So this guy is 2 over 36. And this guy is 3 over 36. And this one is 4, 5. This one's 6 over 36. And then it starts going back down again. These are all over 36. The 7, which is the most likely, there's 6 ways to get a 7. The first die can be either a 1, 2, 3, 4, 5, 6, and then the second one can be 6, 5, 4, 3, 2, 1. So let's check. Are both rules satisfied, our basic rules? All right, the first one was that they all had to be between 0 and 1. 0 and 1. And that answer is yes. These are all fractions. The smallest is 1 over 36. The biggest is 6 over 36, or 1/6. Do they sum to 1? And if you added all these together, 1 over 36 plus 2 over 36 plus 5 plus 1 over 36. You would find that if I added up all of those numerators, this is going to be, these would all be over 36. So this would be 1 plus 2 plus 5, all the way to 1. But that, in fact, adds up to 36 divided by 36, which is 1. All right, so that's what it needs to be a model, and so that works. All right, so an unusual, so here's another definition of sorts. All right, so if we call an event unusual, this means it has a low probability. And usually in statistics, all right, so let's just put this up. In stats, we tend to think this is if the probability is less than 0.05. Or 1 in 20. This is 1/20th, so 0.05. Another way, this is 1/20. We could write it as 5% as well. So if it's less than any of those, then it is unusual. So our snake eye is unusual. Unusual. All right, so the probability of snake eyes, let's call that, we'll call that event 8. Probability of snake eyes, let's see, use this, we'll call E means getting snake eyes. This is 1/36, which actually I know because 36 is bigger than 20, it's less than 20, but let's go ahead and calculate what that is. So we come over and get our calculator, 1 divided by 36, and that is 0.028. All right, so is that unusual? Well, 0.028 is less than 0.05. So yes. Since 0.028 is less than 0.05, then we call it unusual. We also talk about likely events. So what do we call something that's a likely event? All right, so a likely event has high probability, a near 1. So in stats, we would say this is if the probability is bigger than 0.95. Okay. So then we got to ask ourselves, is rolling a 7, and we'll call that event F. Is that likely? Well, let's find out what a 7 is. So probability of rolling a 7, this is 6/36, or 1/6. So even that's the most likely event. 1/6, go to our calculator, 1 divided by 6 is 0.167. So no, it's not likely. And that is since 0.167 is way less than 0.95. So we wouldn't call it unlikely either because it's bigger than 0.05.